We are going to discuss about elements of building construction. So what are the various components that are there in a building? What are the elements of building? We are going to discuss in detail. So let us move into the video. So commonly, if you see, the building components can be classified. The building components are classified into two types. First one is the superstructure, another one is the substructure. Means if this is the ground level, the structure which was there below the ground level is referred as the substructure, and the structure which was constructed above the ground level is referred as the superstructure. So this is a superstructure and this is a substructure which was below the ground level. This is the ground level and this is the ground level. So the structure which was above the ground level is referred as a superstructure, and the structure which was above the below the ground level is referred as the substructure. So this is a basic classification related to components. So if you see the superstructure, the structure which is above the ground and it serves for the purpose of building for the intended use. Means for which purpose you are constructing that building or that particular structure, for that purpose it is useful. That is what we call superstructure. So what are the components this superstructure is having? If you see the components of the superstructure: plinth walls and columns, beams, arches, roofs and slabs, lintels and arches, judges, parapet, steps and stairs. So all these are components of the superstructure what we are constructing above the ground level. So coming to the substructure. So what is this substructure? Means the substructure is the lower portion of the building, so which is below the ground surface. That is what we call substructure, as I told earlier. So which is located below the ground level and which transmits the load of the superstructure to the subsoil. So the load which was coming above this ground level because of the superstructure what you are constructing, what is the load? That load is going to be transferred through this foundation. So this foundation is going to transmit the load. The load is going to be distributed from the superstructure to the substructure, from the substructure to the ground surface or to the soil. So for the the main purpose of the substructure is to transmit the load of the superstructure to the subsoil. So what does it include? What is the substructure? Means it includes the foundation of the superstructure. The foundation of the entire structure is what we call as substructure. So coming to the nominal dimensions, what are the dimensions of the building components? Dimensions, if you see, what is the plinth height? It may be varying from type of building. So it may be from 30 centimeters to 90 centimeters. It may be increasing from 30 to 90 centimeters. 90 centimeters height is also adopted. 30 centimeters is also adopted based on the road height also. Next one, wall thickness. So partition walls will be generally 10 centimeters thick, whereas load bearing walls, which are heavy walls, may be around 20 centimeters, 30 centimeters and 40 centimeters also. Next, lintel. Coming to the lintel thickness, it is around 15 centimeters. Next, chajjas projections will be 30 centimeter, 45 up to 90 centimeters also. Chajjas will be provided based on the protection required. Next, slab thickness, if you see, 1.1 to 0.15 meters, means 100 centimeters to 150 centimeters thickness will be adopted for the slab construction. Slab thickness. Parapet wall thickness will be around 10 centimeters thick. Parapet wall height, if you see, height of the parapet wall, it will be around 1 meter. Next, doors. Coming to the door width of the door will be more prominently used is 1 meter or 1.2 meter, and lesser width also will be adopted for kitchen, similarly for puja room or for a storage room, storeroom, or for a bathroom, etc. will be using door width will be smaller. Next, height of the door also similar way will be adopting generally 1.8, 1.5, 1 and 1.5, 1.8 like that. 2.1 means mostly for public buildings will be using 2.1, and 3 also will be using for public buildings. Door height, sill height will be around 0.07 to 0.1 meters. Lintel height, if you see, lintel height will be around 2 meters from the floor level. So above the basement level we will be having a floor level. Above that floor level, from floor level 2 meters height, above 2 meters height will be providing the lintel. So the height of the lintel will be 2 meters from the floor level. So coming to the dimensions of the building. So building components we have seen. So building elements, what are the elements you are using in the building or components? So in that components, what is the sizes you are adopting? Column size 20 by 20 centimeters square, or 30 by 30 centimeters, or 20 by 30 centimeters. We'll be using circular columns means 20 centimeter dia or 30 centimeters dia. Both will be adopted. Column footing mostly 1 meter by 1 meter by 1 meter, means 1 meter length, 1 meter width, and 1 meter depth is the general dimension for column footing. Or more also will be adopting based on the soil characteristics or based on the strength characteristics of that particular soil. Most used depth is 1.5 meters. Depth of the footing we will be using is 1.5 meters. Width also 1.5 is more commonly used. Next, depth of beams. Beam thickness, if you see the depth of beam, it will be around 30 centimeters, 45 centimeters, and 60 centimeters based on the loads which were coming over there on the superstructure. Next, coming to the steps. Steps include two types, rise and thread. So number of rises is equal to height of the ceiling plus slab thickness divided by riser height. So from this you are going to get number of rises, and number of threads equal to number of riser minus 1. So this way you are going to calculate number of steps required. Riser height will be, you see here, like this. This is the riser, and this is the thread. It is the riser and it is the thread. So riser height will be 15 to 20 centimeters, and thread will be 25, 30, 35. More we have to adopt than to the riser. Next, width of the steps is 1 meter. Minimum of 1 meter width we have to adopt for steps, so that easy conveyance is there. Next, coming to the foundations. The basic function of the foundation is to transmit the load from the building to the subsoil in such a way that settlement are within the permissible limit. So in order to transmit the loads and also to minimize the settlements, two functions are there. First one is to transmit the load transmission. Second one is the settlement. This is first one and this is second one. The soil does not fail in shear. So when settlements are controlled and the transmission of load is proper, so failing of soil is reduce the load intensity. Intensity of load acting at the bottom is going to be reduced because of the distribution, even distribution of load. Because of the even distribution of load intensity is also going to get reduced. And also to provide a level surface on the superstructure. So when the foundation is laid properly, superstructure also will be proper. The superstructure is greatly affected by this foundation. Now coming to the superstructure. Superstructure means the structure what we are going to construct above the foundation level, above the ground level. What are the components you are constructing? That all components comes under superstructure. So first one is the plinth. Plinth is the part of the building between surrounding ground surface and the floor space immediately. So in between the floor level, in between the ground level, this may be the floor level, and this may be the ground level. So in between this ground level and floor level, we will be having a intermediate one, that is what we call plinth level. So the plinth is the part of the building between surrounding ground surface and floor space immediately above the ground. So plinth resists the entry of the rainwater into the inside of the building, entry of animals, insects and rodents. So when the building floor level is going to come, or it is going to be raised greatly because of this plinth. If you are providing the plinth to more depth, if the height of the plinth is more, then definitely it will be above more, it will be having more height above the ground level. So easy entry of water is resisted, similarly easy entry of animals is resisted, and easy entry of insects and other snakes, etc., rodents are prevented here. So because of the high rise of plinth. Next one, general plinth height is 45 centimeters, 60 centimeters, 90 centimeters, 120 centimeters is also adopted. In some areas 1.5 meters. 1.5 meters is also adopted. Mainly in the flood prone areas. 2 meters, 1.5 meters or 2 meters is plinth height will be adopted in order to avoid inflow of water during the heavy flood period. So that is about a plinth. So that way plinth is very useful in the structure. Next one, walls. So the walls are the building blocks of the brick. Walls are laid with the building blocks, what we call bricks or stones. Stones and bricks are the building blocks. So with the help of the stones and bricks, we are going to lay the wall. So they divide the building space into various space or various rooms. So we are going to categorize the floor area into various rooms by providing partition. That partition is provided with the help of these walls. So they support the slab and the beam. Another important thing with the wall is for the support to slab and beams. The slab and beams what we are providing, they are going to be supported by this wall what we are constructing below. They safely transfer the loads coming onto them from beams and slabs to the foundation. So they act as a barrier here. Why? Because they are going to transmit the load from the from the roof to the foundation. So in between the roof and foundation we are having wall. So the load is going to be transferred. Load from the roof is going to be transferred to the load from the roof is load from the roof is going to be transmitted here. Next, another advantage, they provide privacy and protection against heat, cold, rain, noise, dust, wind, etc. So the walls are the things which are going to provide us protection. They are going to provide us privacy. Privacy is going to be provided for the people who are living in that house because of these walls only. So that is why it is very important. Next, they offer resistance to firewalls also. Fire is also going to be resisted by these walls. So we are having two types of masonry. If you are using brick as the building unit, then it is called brick masonry for construction of walls. If you are using stone as the building unit, building block, then we will be saying it as a stone masonry. So here you can see walls which were constructed with bricks and walls which are constructed with stones. Next component, coming to the next, another very important component is the columns or pillars we call. So columns are the vertical members along which the beams and slab roof is supported. They are square, rectangular, circular and circular in shape and in cross section. The cross section of the column may be circular or it may be square or it may be rectangle. So these are the vertical members on which the beams are going to be laid. So this is the beam. The vertical member is called column. The horizontal member is called beam and a vertical member is called column. So these columns are also very important for load transfer also. The load of the structure is going to be, or the roof is going to be transferred to the either through column or either through wall. Mainly in case of framed structures, most of the time columns play very major role. Next component is floor. A floor is a plain area to support occupants, furniture and equipment. So floor is required to provide a smooth surface and a plain area to support the occupants, or to provide or to facilitate the occupants. Next, to provide access for the furniture and equipments. In order to place the equipment or in order to place the furniture, good flooring is required. Another important thing is roofing. The uppermost part of the building constitutes of roof. So the topmost part is the roof. So on that only we are going to, on the walls, finally we are going to close the open space of the building or the rooms with the floor roof. So the roof is the uppermost part of the building, constitutes the roof. The slab and the roof encloses the space and offer protection from the rain, heat, snow, and wind, sound, fire, etc. So mainly the purpose of the roof is to provide protection against rain. Rain is going to be avoided by providing roof. Next, heat is going to be reduced by providing roof. Snowfall is reduced, snowfall is prevented, wind is prevented, sound is prevented, and fire is also going to be prevented with the provision of providing roof, proper roof. So if you see the thickness of the slabs may be 10 centimeters thick, 12 centimeters, 15 centimeters, means 100 mm to 150 mm, 100 mm to 150 mm. This is the thickness of the slab we are adopting. So here you can see different types of columns. It is a square column, rectangular column, circular column, circular cross section. Column cross section is circular. Roof slab. So here you can see this is the open space, open top. So over that open top we are going to provide a roofing. Next one, flooring. Flooring is also very important for facilitating the occupants. So the flooring may be any of type, either it may be wood flooring, or either it may be tile flooring, or either it may be cement flooring. Next, another important component is doors and windows. So doors provide a connecting link between the rooms, allowing easy free movement in between into the building and in between the rooms of the building. So in order to move from one room to another room, we require doors. In order to move from out of the building to the into the building, or into from inside of the building to the outside of the building, we require doors. So next, windows are openings provided in the walls, so for the purpose of providing ventilation and light. So doors and windows together will provide lighting and ventilation. So light is going to be provided into the building, ventilation is going to be provided into the building. They provide resistance to weather, sound and heat. They provide security and privacy. So these are the uses of doors and windows. So general sizes, most frequently used sizes of the doors, if you see for residential buildings, internal doors will be 0.9 meters by 2 meters. Height is 2 meters and width is 0.9 meters. External doors will be 1.2 meters by 2 meters. For bathrooms and water closets, the width will be little bit lesser. So width of the door will be less, 0.75, and height will be same, 2 meters. In case of industrial buildings, width may be more and more, or in case of public buildings also, width of the door may be more. So 1.5 meter, 2 meter, 2.5 meter will be used in case of public buildings and industrial buildings, like function halls. If you see a function hall, width of the door will be very much. Similarly, if you see a meeting hall, there also width of the door will be more. Next, depth or height will be 2 meters or 2.5 meters. Height of the door also will be more here in case of industrial buildings or in case of public buildings. Next, types of doors. If you see various types of doors, one has to know there are several types: battened and ledged door, battened and braced door, battened and framed door, battened, ledged and framed door, framed and panel door, glazed door, flush door, lowered door, wire guarded door, revolving door, sliding door, swing door, collapsible steel door, rolling shutter door, mild steel door, hollow metal door, PVC door. So all these are different types of doors. We can see the images now. See here, this is the batten door. So in the batten door, battens will be there, supporting battens will be there at the back side. So these are the battens, supporting battens, and it will be having individual pieces will be combined together to form a single door or to form into a door panel. Batten and braced door. So along with the battens, bracing is provided here. So these are the bracings. So batten and braced door. Next, batten, ledge and frame door. So a frame will be there, outer frame. In between that, ledges will be there and battens will be there. All these are battens. So three components are involved in here: batten, ledged and framed door. Next, framed and panel door. Framing will be there with panels. This is the frame, outer frame, and inside there will be panels. So all these are panels. So framed and panel door. Glazed door. So glazed door means in between panels, instead of panels we'll be using glass pieces. Glass pieces are used in the frames, then it is called glazed door. Flush door. Flush door means single unit, single door. As a single door if you are making, then it is called flush door. Lower door. Lower door means small air gaps will be there, small sleeves will be there in between, then it is called lower door. Revolving door, which can rotate with a pivot axis here. This is the axis. Along this axis it is going to rotate. It will be rotating this way and it will be rotating this way, then it is called revolving door. Mostly we see this in parks. Next is sliding door, which slide one over the other. Sliding door. Next, collapsible door. Collapsible door means it is nothing but a grill door which can collapse to one side, which can fold, which can be folded. That is collapsible door. Rolling shutter, which can be rolled to the top. Rolling shutter. Mostly for shopping malls we will be seeing rolling shutters. Next, hollow metal steel door. So instead of using wooden panels and wooden door, if you use a metal door which is hollow inside, then it is called hollow metal door. PVC doors. Instead of wood and metal, if you are using PVC, polyvinyl chloride. PVC, if you are using for making this door panels and door frames, then it is called PVC door. So size of windows, if you see the size of windows, size is little bit different. The size of the window may be 0.6 to 0.6, 0.6 to 1.8. Maximum width is 1.8, minimum width is 0.6. Next, depth also like that, only 0.6 to 1.8 meter. So mostly the windows may be rectangular and square also. Rectangular windows will be there, square windows will be there. Single pane window will be there, two panes will be there, and three pane window will be there. Next, size of the ventilator. Ventilators are also used as part of the building for air circulation. So width is 0.3, 0.4, 0.6, 0.75 and 0.9 width of the ventilator. And depth, if we see, depth will be very less, 0.25 meter, means around 250 150 mm or 200 mm, 150 mm or 200 mm or 250 mm maximum will be using as the width of the ventilator, depth of the ventilator. So next, coming to the types of windows, if you see, there are so many types. Fixed windows, mostly we see in houses, residential buildings, or fixed windows. Pivoted windows, double hung windows, sliding windows, casement, sash, lowered, metal, bray, corner windows, dormer windows, gable windows, lantern windows, skylight windows. Here you can see this is a pivoted window which can be rotated. The door can be rotated. Next one, double hung window. Two panes will be there. Next, a sliding window. This is also most commonly seen, sliding window. Casement window, which consists of individual glass door, and in between that we'll be having a grill, that is casement window. Sash window, one portion will be plain glass and one portion will be casement, both will be there, then it is called sash window. Lowered window means small sleeves will be there. Here you can see small sleeves. Next, bay window with a projection like this, then it is called bay window. More access for lighting is there. More light can more light can be experienced inside the room because of these bay windows. Why? Because it is having a different shape. Next, dormer window. Dormer window is seen in the tiled roof. Mainly in case of tiled roofs, we can see dormer windows. Next, gable window. Gable window also in case of tiled roofs, we will be seeing gable windows. Skylight window for providing light in the corner rooms. We'll be using skylight windows for lighting, proper lighting into the corner rooms in the building, where lighting is very much less. No windows can be possible to provide on the walls. Then we'll be providing the window in the roof. Then it is called skylight window. Lantern window. Lantern window means more amount of area. If you are providing this window with with more necessity of light, then it is called lantern window. Corner window, at the corner if you are providing window, then it is called corner window. Next component is sill. Sill means the bottom, the lower portion of the window is called sill, and the ventilator opening. Window and ventilator opening, if the bottom portion is called, this is what we call sill, and the bottommost is called apron. Next, the last one, steps and stairs. So steps and stairs are meant to provide access between the different levels. In order to provide the access for building, we are going to lay these steps. Similarly, in order to provide access to the next level or the first floor, we will be providing these stairs. So mainly one flight, maximum 8 steps should be provided. For more than 8 steps, it should be recommended to provide them with landing. So when we are providing steps, landing should be there. So this is what we call landing. So when the maximum number of steps is more than 8, if you are providing more than 8 steps, then we have to provide a landing. So generally for residential buildings, width of the stair is 1 meter and 1.2 meter. Number of risers is equal to total height of the floor by height of the riser, and number of threads equal to number of riser minus 1. This is about steps. Here you can see this is for entering into the building, and this is for higher levels. So stair terminology. So there are several stairs terminology. If you see headers and riser, header, run off flight, handrail. Next, total rise of flight, floor level, stair. All these are stair terminology. Next, beams. What is this beam means? Beams are the horizontal members which are provided in order to support the slab system, or the slab panels are going to be supported because of these beams. Beams are instead supported on the walls and columns. So beams are supported by walls and columns, and these beams are going to support the slabs. They are generally 20, 39, 45, 60 centimeters thick and deep members as per structural design. So all these are beams. So coming to lintels and arch. So lintels are the horizontal members which were provided above the opening. So above the openings we are going to provide these lintels in order to support the portion of the wall which was constructed above this opening, and also for the transfer of load because of the because of the wall portion which was above this opening. Next, arch. Coming to the arch is normally a curved member comprising of wedge-shaped building blocks pulling each other with mutual pressure. So wedge-shaped blocks will be using here for load transfer instead of using a lintel, then it is called arch. And in a circular shape or in a curved shape, if you are adopting that wedge blocks, arranging that wedge blocks, then it is called arch. So the purpose of lintel and arch is same, but here we'll be using some skilled arrangement, skilled labor is required here, but here it is not required that much. Simply if you are laying concrete or wooden member, that is sufficient. Next one, chajjas. So chajjas are provided on the external wall openings to get protection from rain, snow, and they are the weather shades. In order to provide protection from openings, protection for the openings, we are going to provide this chajjas. What we call is a sunshade we call. The thickness is from 100 to 75 mm and projection is 30 to 90 centimeters. Projection outside projection is 90 to 30 centimeters. Next, parapet. Parapet wall is generally 10 centimeters thick partition wall constructed above the slab to enclose the terrace open to sky. Thickness is 10 to 15 centimeters. Height is 1 to 1.2 meters. 1 meter to 1.2 meters is the height of the parapet wall, and 10 to 15 centimeters is the thickness of the parapet wall. Generally 10 centimeters thick parapet wall is sufficient. So this is about various components of the building in detail manner. Hope you all understand well. Thank you.